Hi, welcome to the channel Coders Arc, where we unravel the world of coding and architecture together. And today I'm going to talk about HTTPS, or the Hypertext Transfer Protocol Secure. In this video, I'm going to visually and conceptually cover the core concepts of symmetric encryption, asymmetric encryption, certificate authorities, and the HTTPS. Now, I'm not going to go in depth into RSA, TLS, or the SSL algorithms because my goal is to make you just visually understand the basics of the HTTPS flow. In my years of conducting interviews with various architects and developers, as well as having casual conversations with various technical folks, I have observed that most people do not understand the concepts of HTTPS or may understand it on a very surface level. So hopefully through this video, you will be able to understand more in depth. Feel free to pause the videos at various spots to take screenshots or look at the video and observe the material. So hopefully it will be much more clearer to you. So let's dive right into it. Before we understand how HTTPS works, let's understand what symmetric encryption and asymmetric encryption means. To understand what symmetric encryption means, let's take a look at this example. We have a user Alice who wants to communicate with user Bob over the internet. She wants to send a message, but she cannot send the message in its plain form because anybody can read that message and get some confidential information out of this message. So there is a concept of symmetric key. It is essentially the same key that is available to both Alice and Bob, the sender and the receiver, and they can use this key to encrypt the message and decrypt the message. So Alice sends a message encrypted using the symmetric key over the internet to Bob, and Bob receives that message and uses the symmetric key to decrypt that message. While this approach provides one layer of security instead of sending the message in its plain form by encrypting the message using symmetric key, it is still not the most secure approach. And that's because any bad actor can get hold of the symmetric key and use that symmetric key to decrypt that message and get the confidential information out of it. So let's take a look at how asymmetric encryption helps solve this problem. In asymmetric encryption, you have the same problem of a user Alice trying to communicate with user Bob over the internet. She wants to send a message securely. Now, we have the concept of public and private key pairs, where each sender and receiver who are trying to communicate with each other generates this pair using an algorithm like RSA algorithm. Essentially, what the concept of public and private key pair is that a sender and receiver who are trying to communicate with each other, they will generate a pair of keys called the public keys and the private keys. The private keys are only held securely by the sender. So in case Alice wants to communicate with Bob, she will keep her private key securely with herself. And same, if Bob is trying to communicate with Alice, he will keep the private key securely within himself. Now, the public key is available to all the users that they are trying to communicate with. So for example, Alice, if she's trying to send a message to Bob, she will exchange her public key. She will receive the public key of Bob, and Bob will receive the public key of Alice. And now, when Alice is trying to send a message, she will encrypt the message using Bob's public key. It is important because the only person who can decrypt this message now is Bob, because Bob has the private key. So important thing to note here is that any message that is encrypted using the public key can only be decrypted by the user who has the private key. And that's the way the public and private key concept works. So when Bob receives a message, he's going to use the private key and decrypt that message. Again, you would ask, what if there is a bad actor in between who intercepts over the wire and gets this message that was encrypted using Bob's public key? They will not be able to do anything with that message because they don't have Bob's private key. So that's how asymmetric encryption helps provide an additional layer of security and is the preferred approach for sending the messages securely over internet. So now, with a good understanding of how symmetric encryption and asymmetric encryption works, let's take a look at how HTTPS works. It's based on both of these concepts. Let's say you have a user who's logged into his browser and wants to access the site www.dummysite.com. Dummysite.com is available over the internet and has its own server. So the user will send a message, let's say hello, to this site. Before we can see how the dummysite.com responds to the user, let's understand the concept of certificate authority. Certificate authority is nothing but a trusted entity that issues the digital certificates to authenticate the content sent from web servers. So in this case, the dummysite.com is going to send a certificate to certificate authority, basically asking, hey, I'm dummysite.com and I'm giving you some information about myself. Can you please validate that I'm dummysite.com? Certificate authority is going to digitally sign this certificate using the asymmetric encryption and sends the certificate back to the dummysite.com. It is important because certificate authority acts as a third party that will allow both sender and receiver to verify each other's identities. So finally, the dummysite.com now is digitally signed by certificate authority and is going to send a message back to the browser using the public key. So over the wire, the dummysite.com sends a certificate and includes its public key so that the receiver, the user's browser, receives that message. Finally, when the user browser receives that message containing the public key and the digitally signed certificate, it wants to validate that this message is actually coming from dummysite.com. So it uses the certificate authority, and most browsers, most PCs that come these days have the certificate authority validation and verification already installed on them. So the browser makes a request to the certificate authority with this certificate and asks to verify and validate that it is actually indeed coming from dummysite.com. So here, if there is a bad actor and they send their certificate, it will be rejected by certificate authority because certificate authority will know which certificate it had signed. So finally, when certificate authority validates that the request is indeed coming from dummysite.com, it lets the browser know that, and the browser feels comfortable about sending a secret to the dummysite.com. So the browser now constructs a payload that contains the original certificate from the server, which contained the public key of the server, and also a newly generated secret so that the dummysite.com can receive that secret. So now this payload is sent over the internet so that the dummysite.com can receive it. Finally, the dummysite.com receives the payload containing the certificate and the new secret. At this point, there are only two entities in the world that contain the newly generated secret, and that's the user's browser and the www.dummysite.com. And that's because the asymmetric encryption along with the certificate authority validation was used to send the payload. You may wonder what happens if a bad actor gets hold of the message while it is being sent from the browser to dummysite.com and tries to change the secret. Well, that will not work because we have used asymmetric encryption using the public key of the server to send the message, so that let's say even if a bad actor gets hold of the message, they will not be able to decrypt that message because they don't have the private key of the dummysite.com. So one very, very important thing to note here is in the asymmetric encryption that the sender and the receiver keep their private keys as securely as possible. Because if the private key is compromised, then this system will not work. And finally, now the dummysite.com can actually start sending the real payloads back over to the browser. So these could be in the form of HTTPS requests, using the messages like get, put, post, patch, delete, etc. But the point here is that the messages that will be sent back to the browser will now be encrypted using the secret key, which only 2 users in the world have that secret key, and it is sent over the wire, and the browser receives that message, and since it has the original secret, it decrypts that message and starts doing the work with that. So this is essentially how HTTPS works. So in this video, we covered how symmetric and asymmetric encryption work. We also covered how the combination of symmetric and asymmetric encryption, along with the concepts of certificate authority verification, validation, and digital signature, help us achieve the HTTPS flow. So, if you found the value in this content useful, please hit the subscribe and the like button, and please also let me know in the comment section what other videos you would like to see. For now, goodbye.